All right, I think I'm going to get started. So I'll introduce myself. Hi, everybody. I'm Ian. You might have seen me at the Slimming Pain talk. I'm going to talk about a UIWorker idea that I've been exploring. It's in sort of a newish state, so in traditional BlinkOn style, it will be a little bit half-baked in places, but I will at least have a demo to show you. And hopefully, my goal for this discussion is to introduce the concept, show you the idea, talk about the API that I presented in my first formulation, look at what a nicer API might look like, and get the discussion rolling. So, went too far there. So the problem that UIWorker is trying to address, there are two of them really. One, it's really tough to write performant code that's fast on all major browsers, and you can't write custom code, code that can't synchronize your JavaScript-driven effects in sync with your accelerated effects like scrolling. So that performant cross-UI code, I've heard it described as the tightrope. Those few properties, those few CSS properties that are fast. So what, at a high level, I'm looking for is maybe Rails for the tightrope, so it's easy to get across it. And hopefully, we can grow that tightrope. But I'd like to emphasize something. This is not an alternative to making everything else fast. Because while it would be really nice to get across that tightrope easily, it would also be amazing if we could, as Nat said, make all 115 of those CSS properties fast. So there's sort of complementary things going on here. So with that said, let's talk about how we might make a pit of success or an easier to walk across tightrope. Some things that are tough to do in JavaScript in the face of a lot of main thread jank is moving stuff around. So if you stick your finger down on a thing and try to move that thing, and you're affecting that movement via JavaScript, and you've got a janky main thread, you might see hiccups as it slips out from underneath your finger. Parallaxing stuff via JS. Also tricky. If you've got jank, you might see the thing slipping in the background if your scroll is being serviced at a different rate than your JavaScript that's driving the background is getting moved around. There are hacks that you can, not hacks, there are techniques that you can employ to make these things performant. For example, for the dragging stuff, we could imagine an enormous two-dimensional scroller that you sort of pan around with your finger. So you could do something like that. Or for parallax, you can do some transform stuff to actually push the background via perspective. But it's not extensible. And here are some other things that are tricky to do. But as Rick was saying in the other talk, what we really need to do is empower developers to innovate. We need these things to be extensible so that we're not married to those very few effects that we can do quickly. And so we're faced with kind of a bit of a bummer of a trade-off here where we're choosing between extensibility via script and these blessed effects or these tricks that let us be fast on all browsers. Is there a way that we can do both of these things? And the answer is kind of sort of. We can sort of do both things. You can, like I said, we're going to try to walk across that tightrope easily, and that'll let you animate things like, transform opacity and scroll, and maybe we can throw some more stuff in there, like your shadow size. You could probably have a non-layout inducing size change. There's a palette of effects that you could affect in this way today, probably in the not too distant future, but some stuff's going to be a lot harder to do this way. For example, layout inducing properties, to try to do that really quickly is going to be tricky. So yeah, we can sort of get the extensibility that we want and performance, but our palette currently is a little bit smaller. So to talk about the concepts, I'm going to sort of rewind and show some pictures that are in line with the Slimming Paint talk that was given earlier. So imagine this is your page. Each one of these tiny little rects here is a draw operation. The first one might be, I want to paint the background white, and some of them might be, I'm going to draw some text. One of them might be transform, say, and we've got some draw operations that are affected by that transform. So when you muck with that, they fly around on the screen, say. And the question is, say that transform is, say I want to mutate that transform in sync with an accelerated effect. Is there a way that I can do that in sync with, accelerated scroll or touches that are coming in on the thread? Yeah, you can. It's trivial to do it on the main thread in sync. So if we use the scroll delay technique and put it on the main thread, it's very easy and straightforward to see how you would make it in sync. You just write JavaScript as you're used to. But let's talk about the threaded case because it's a little trickier. So this is a bit of an inaccurate picture, but what I'm attempting to show you in this picture is that we've got sort of two copies of the world. We've got the main thread copy of the world and the compositor thread copy of the world, and they might be slightly out of sync. That's why I've got the different color on the end there. Some bits of it are in common, and we need a way to refer to the stuff that's in common. So somehow we want to say there's this thing that's in both lists here, and you're going to declare the thing that you want to muck with. And we need a stable identifier by which we can find that knob to turn, say. And then what we want to do is have the ability to muck with that thing that we've named and got an identifier for on the thread. So at a high level, that's the thing that we're going for. And so I was wondering what that might look like. And one way that you might imagine doing this is very directly with a worker. So first thing you need to do is get that diamond to get that stable identifier. And to do that, in this snippet here, you might, and I should preface this by saying this is my pretty horrible API, but this is a way that one might do this. We'll talk about nicer APIs later. So to get the bound stable identifier, you would say spinner. I would like a stable identifier for your transform, and that gives you a handle to that knob. And in this example here, I'm passing it over to a new kind of worker, a UIWorker, which runs its JavaScript in sync with the compositor thread. And so on the compositor thread, what would it look like? Well, you've got your on message, and the token would get delivered to you. And we're going to run something that's very much like RAF, but it's slightly different in that we declare the things that we're going to muck with in RAF, which is kind of nice because you can prepare for it. You sort of know the things that you're going to be moving around. So you might say, make sure that it's all rastered and ready to see when it flies in. So in my crappy formulation, I create a special context out of the knobs I'm going to turn. I call RAF on it. And RAF looks like this. You get the context passed into you, and it's all freshened up so that you can grab the current value of that thing you have the identifier for. So we grab that matrix. And based on the current time, we do a really cheesy animation, and we slide it around, translate it back and forth, and then we set that thing using this API, and we request another frame so that we continue ticking. And I implemented it, and I'm going to show you the thing working here. It's going to be really slow, so it's not going to be particularly sexy, but I encourage you to come up and take a look at it on the laptop afterwards where, you know, refresh rates are a little bit prettier. Is anything showing on the screen there at all? No, things are jammed here. One moment, I'm going to have to leave and join the thing again. Brief technical difficulties, sorry. Here we go. Go present. Join. Share my desktop. Start the screen share. Can you see a thing? There it is. There's the thing. All right. So here's the thing. And you can see, although it's extremely chunky, that the scroller and the thing that's fading in and out and sliding side to side are being updated at a different rate than the thing that is main thread RAF driven. I've artificially induced horrendous main thread jank here, which is why you see the RAF animated thing skipping. It definitely does not obey the Midnight Train guidelines. It's a very naughty thing that I was doing there. I have a couple of other examples. This one has the background listening to scroll top. That's one of the stable identifiers, and the other one is the transform of the background. And so this parallax here, which is in sync, is being driven by JavaScript. I've also got this sort of fancy thing here, which doesn't look particularly fancy over there, but it's not repainting and can snap down. Oh, this is just grody on the screen. We're going to forget that example. But I think one thing that would be interesting to take a look at is like what does the code that I wrote to actually realize these demos look like? And so I want to bring up the source for these because I think you might find that interesting. I am not good at this presenting thing. I apologize, everybody. So one sec, let me get this thing presented again. present for There we go. So here's, oh, that's really small. That's terrible to look at. Nice and big. Is that big enough to read now? Yeah, so the interesting stuff is this stuff up here. The rest of it is me setting up the main thread spinner. So you see I've made the UIWorker and pointed it at the script that's going to run. I've grabbed my two elements that I care about, you know, the spinner and the scroller, and I bind up some properties just the way you would expect, and I pass them over as in my the example that I gave earlier on the slides. The rest of this is about the setting up of the main thread RAF thing. So what's happening on the worker? Also too small to see, right? Yeah, make that bigger. So I've got my onMessage function where I grab my tokens and remember my tokens. Now my API is named incorrectly here because I had named all the functions different things in my work in progress patch. So ignore that for now. But I create my special context with my tokens, and I call my special RAF function, and it does what I showed in the slides as well. It grabs the timestamp, updates the matrix and the scroll position in response to those time ticks there. So that's that. But getting back to my thing here, now that we've demoed, present again. But the API is pretty clunky. Using things like opaque tokens and contexts and whatnot doesn't feel particularly webby. And you'll notice that the issue, which is a big one, of input has been dodged entirely. So what might we do to make this API look a little bit nicer? I had a couple of ideas for how we could go from UIWorker to something that might be a bit more palatable. One is very like incremental improvement on UIWorker, where and I've shortened bind animated property to bind so it would fit on the line there, but ignore that. You teach it how to bind up to eventy type stuff. I would like to bind up to touches that involve this element, or I would like to, in the spirit of the thing that was presented by Tim and Rick, I would like to bind up to the before scroll so that I can consume some scroll deltas that are being sent to the element. It's still a little bit clunky looking, but this would at least get us processing input. Something else we might do is related to the animation proxy thing that I'd suggested last year, where you would ask for a proxy that you could pass over to a worker that stands in for the element, but only lets you touch a few properties on it. And you might, when you get the proxy, declare ahead of time which things on it you'd like to touch. For example, I want to muck with this thing's transform, say. And that would give me a proxy object that I could pass over to the thread, and I could, much more naturally than saying context get matrix token, I could say transform equals the thing, which is a little bit nicer. It feels a little bit more OO and all of that. Something that might also be nice is if we were to directly represent the dependency graph, the scene graph that is represented by these functions. For example, if you have just a straight wall clock driven animation, your input is the wall clock, and it might say drive the e.transform, say. Some things might depend on the scroll top of other things. Some things might depend on touch input. Some things, and in that way, if you're able to somehow represent these edges, what your job would be on the compositor thread every frame is to determine what's changed and clean up the graph minimally. So for example, if on this frame we've ticked the clock, as we will always tick the clock, and if we happen to have a new touch event, these two nodes in the DAG might be dirty. And then we could update these two things. And since the order of these doesn't matter, we could update them on a couple of threads at once. We've got a lot of scheduling options for this. It really doesn't matter. And then we could update the next dependent properties. One nice way to represent this is using the pure functions that Ian Kilpatrick was talking about earlier when he was giving the overview of glitter. But this is stuff that doesn't exist currently in JavaScript. So it sort of would be wonderful if you could do this, but it's not something you could currently do. But if you could, it would be nice to say this transform, it's bound up via this pure function to this other thing scroll top. And that would be a really legible way of expressing parallax, say. And you could imagine, if you could do this, that you could create a library of such edges that you could plug in however you'd like. You create a parallax, a generic parallax edge, and you could say, I would like to use that parallax and fancy bind it up to that thing scroll top with a rate parameter of 0.8 or a rate parameter of 0.2. This might be a convenient way to rig up this graph, but again, it relies on stuff that doesn't exist at the moment. Similarly, we can do things with before scroll, and we could also affect the bubbling order. This is stuff that I actually haven't vetted with Rick and Tim yet, so take that with a grain of salt. This might be completely bogus. And you could also represent a traditional animation by binding up to some special time thing. In such a way, you could get the animation moving, or you could bind up to inputs. So those are some of the ideas that I'm considering for the API. And later I'm going to link to an explainer document. And if you've got ideas for how this API could be improved or a better shape for threading in general, I'd encourage you to comment on that thing there. But what's next for this prototype that I'd written? Well, the hope is that it could get landed behind a flag, and we can start implementing some of the tough cases that we're trying to handle on the input team, that we could start implementing a pull to refresh on it. We can see where it would fall down. So that's what will be coming soon. There's a bug to track that progress if you're interested to see how that experiment goes. And so hopefully we'll get that thing landed and we'll play around with it and see if the API shape is actually useful. I'm going to stop at this point and let anybody ask questions if you've got them. Yes?
So I didn't get, if you're changing the transform in the UI, how is that synchronized?
So the question at the back was, if you're mucking with stuff in the worker, how is that synchronized with the main thread? It's an awesome question. It is something I glossed over. So when we do accelerated scrolling currently, we bundle up the changes that, the compositor thread knows about, but the main thread doesn't. And at commit time, we push it back. And in the same way, in my demo, I'm bundling up all of the changes that I've made to my bound properties and pushing them back, and they get applied on the main thread. So if you were to query these values on the main thread, you will get a flavor of them, but it will be stale. So the compositor thread will tick away, but the main thread will get an out-of-date flavor of that property. Yes?
So building these dependencies becomes pretty complicated to reason. Have you given any thought to what visualization we could do in DevTools, for example, to help developers understand it?
I haven't, and I admit that that's a really tricky. Oh, I'm sorry. I'll repeat the question. The question was, if we're wiring up these graphs, it could get pretty hairy. We could have a lot of edges. Have you given any thought to how we could provide tooling to, help cope with that complexity? And I haven't yet. And you're right, it could get quite hairy. In particular, it might be tricky to figure out a cycle if you introduce it into the graph and we can't resolve some order. And you want to try to figure that out. It's something that I, as a half-baked idea, thought we could just vomit a warning saying that you've got a cycle, but that's not really going to help you narrow down which code is responsible for it. So some sort of graph visualization would be really helpful, but no, I haven't put much thought into that. Harakan.
What's the status of other vendors?
Well, we're sort of, yeah, Harakan asked, what's the status of this with the other vendors? We were speaking last week at TPAC with folks about scroll-linked effects. And there were a number of things proposed. Dean Jackson had some new additions to CSS to pick your time base so you can link up to scroll that way, set your scroll trigger. Rick had also proposed the before scroll. Some folks had asked, is it possible to get the programmatic, the extensibility afforded to you by scroll delay, but also the speed? And so I pitched this thing, and there was favorable responses, but it wasn't particularly definite. Is that a fair summary of it?
Yeah, I think the CSS working group really bought the extensible web argument, right? We should explain what we've got. And the argument against scroll delay is it doesn't explain what we rely on. It explains a simplified version of scroll. this really honestly explains scrolling as we use it today in browsing.
Sticking with you, Rob, you had a question as well. Can I? Rick, I'm a little flustered. Rick, sorry. So what was the question you were going to ask earlier?
Well, I was going to get you to talk about that, but secondly, why don't you talk, to what extent do you think existing parts of Blink and CC could be re-implemented on top of this?
Oh, that's a fantastic question. So I'm hoping that this really... I'm very bad at this, folks. So the question was, what of our existing features could be implemented in terms of this primitive? And it is my sincere hope that we could express our accelerated scrolling and accelerated CSS animations in terms of this primitive. So in that way, CC kind of gets out of the business of producing its own inputs, like rather than, you know, mucking with the tree and then working on that tree, we have some external stuff, this stuff that mutates the tree and it just works with it. It would be kind of nice to get to that point. So that is my hope, is that those things could be implemented in terms of it. Moreover, we've got other features that are coming down the line that we might be interested in implementing, like say snap points or the features that Dean was proposing. It would be great if we could implement those in terms of this primitive. So really, this is the explanation, and we just build stuff on top of that. Yes?
Go back to the example very quickly, because I'd like to understand what is the core data type that a UIWorker is operating on. So you have a context, and that context is just a list of properties that you're operating over.
Yeah, it's a thing that's through which you're able to get the current value of a property you've acquired a token for and set the value of it.
And so I guess in the initial implementation, this is going to be a subset of the available CSS properties. Do we understand to what extent our architecture, but this architecture, are represented with regards to other browser vendors about the set of properties being fast or slow for their compositing operations?
I do. So the question was, you can muck with a subset of properties here, which is absolutely true. The things that you're allowed to bind in this model were the scroll position, your transform, and your opacity. And Alex's question was, do we have an understanding of what that set of fast properties is amongst all the browsers? And I have to admit, I don't have a very clear understanding. I know that those three properties are on the fast path for most browsers, but it would be nice to grow that to be a larger palette, but I don't know what that would look like, and I would need to speak with folks from the browsers to find that out. Yeah. All right.
That was one of the things that came up in the conversation I was speaking to you. I think there's a lot of value, notwithstanding whether we sue UIWorker and actually having that conversation. Because today we all each have a different type of there's some shared things, obvious ones like transform, opacity, scrolling, but reaching interoperability in a larger set of APIs, understanding where different architectures promote certain properties can be fast versus others not is actually useful exercise.
Yep.
I was going to say something similar to that. Do you think, are we deluding ourselves by saying which properties are accelerated as an implementation detail? Is that hurting developers to say that's an implementation detail rather than something that should be standardized as part of the API? If what we're trying to do is enable people to write web apps that are smooth on all browsers.
So Rick's question, I'm going to do a bad job of summarizing this, Rick, but I'm going to do my very best. So are we deluding ourselves by thinking that we could? No, not going to do it.
The fact that transform today is fast and width isn't fast,
Right.
say that's an implementation detail.
Right.
We're free to make that decision as Chrome. Is that good that we said that, or should we really be saying no? We should agree at the W3C.
Right. Okay. So I think I can rephrase it at this point. So what Rick is saying is, we've said that some properties are fast and some aren't slow, but we haven't codified it, officially anywhere, right? It's an implementation detail, and these things happen to be fast. Would it be valuable to agree on and formalize that set? It's an excellent question, and I'm not sure. It would be helpful for those to put rails around those things which we've we intuitively know are fast everywhere, but it might be very valuable to make it explicit. I don't have a great answer to that question. I'll have to look into it. Yeah.
I have a question for maybe both of you.
Sure.
Why don't we just give you a mic over there?
Very sorry. So the question boils down to, is there something about our input and then scheduling and then dispatch and then compositing architecture which implies a particular thread arrangement? And is that baked in, or is that modified in any way by the UIWorker? So for instance, for doing, as you said, touch, move, linked effects, does this now mean that input events should go from whatever our input stack is to the UIWorker first and then to the main thread, or back the other way? And does that improve or reduce our ability to service these sort of effects at 60 Hertz?
That's an awesome question. So I'll talk to it in terms of what I actually implemented first. So the way that the thing is currently implemented, I have to process as we're doing scrolling, which happens sort of earlier in the lifetime of a frame. So we're going to try to do scrolling and bubble that thing up. And if one of these has like a before scroll handler on it, I handle it right then and there. And then I had handled these UIWorker callbacks at the same point in the frame as I did the accelerated CSS animations. But I think it would make a lot of sense to be very explicit about where in the frame these things happen. And one thing that I didn't touch on here, which is very important, is the ordering in which these things are called. You might, for example, have one callback that reads A and sets B, and somebody else needs to read B and set C. And it's very important that you do them in the right order, otherwise you're not going to have things ready. So talking about, when things are scheduled in the frame flow is crucial, and I haven't made that explicit here.
Can I just add?
Yeah.
Just to answer your question, also go back to the question of interoperability, that this explains the architecture we've got, but the architecture isn't arbitrary, right? The architecture is motivated by the fact that we want scrolling to be fast. And since we want scrolling to be fast, it means when a touch event comes in, which is something that can block the scrolling, we've got to send it to the compositor so that it can decide whether it can take the fast path and not send it to Blink. And my understanding is every modern browser does something like that, right? IE has its d-minute thread. Right, Safari, it's a little bit trickier in Safari because they actually integrate with the OS's scrolling system. So I'm trying to get a more clear answer on how well this would fit into Safari. But from what I understand, certainly when I asked the Safari team, they said this fit into their architecture a lot better than scroll delay did, right? Which is a huge signal for me. They said this would be way easier for them to implement Safari than scroll delay, and which is funny because scroll delay is trivial for us to implement, and it's because the way they interact with the way the system scrolls. But I think as long as we're talking about exposing the properties that drive transform opacity and scrolling, those have got to be fast in all browsers. Every modern browser has to be fast on those, or they don't run the web. And so I think it's kind of fake to say, oh, that's an implementation detail. Right? Yeah, it's an implementation detail, just like layout running faster than 10 seconds is an implementation detail, right? If you're free to make that choice, but you're not going to run the web if your layout takes 10 seconds. Unless you're a printer. Unless you're a printer, yes.
From what I understand, Mozilla's APZ async scrolling implementation that they're currently porting to all their different platforms also works in a similar fashion. So in terms of input pipelining.
Yeah, so I don't think there's any good reason why we shouldn't start with this simple model, and we can hopefully agree on that and get some real wins out of that, and then we can say, how do we expand the tightrope? How do we do more? And that's where there's going to be more contention. Like maybe Ian mentioned doing something with shadows, right? Maybe that makes sense for us, but it doesn't make sense for IE, right? But I think it's good for us to that's going to be at the point when the value isn't as high. You don't get as big bang for the buck anyway. Like just being able to handle touch events, scrolling, and transforming would get us like 95% of the use cases, at least the common ones today.
So I have a question for our esteemed speaker. If you have to implement all your effects with just transform, opacity, and clip, how easy is it to author with just those three properties?
It's a great question. It can be quite tricky to author with just those properties. It would be really nice. Oh, I'm done, right? You've got the slide somewhere. You don't need to see that. It's okay that I closed it like a fool. So yeah, it can be pretty tough to work with transforms. It's not as ergonomic an interface as maybe like animating the height of the thing, right? So you'd likely have to go through, maybe if you want it to be particularly friendly, go through a library that would help you out with the transforms. But doing it by hand is a little bit chunky, and some stuff that I think you've run into before, where you want to have shadows done in a particular way, becomes extremely difficult to do in terms of transforms. That was your experience, right?
Yeah, well, I mean, the question becomes for me, it's like, oh crap, now can you do measuring in UIWorker?
Right.
Uh-oh. Another great one is to stretch things. You end up to make something taller with this. Question is, can you animate height?
Right. This is non-layout inducing properties as it stands presently.
So then a really interesting thing is now you have to animate transform with a non-rectangular scale. So you have something that's got an X scale of 1 and a Y scale of, say, 100 or 200. And when you do that, then the amount of memory for that required to get good pixel resolution and caching becomes completely ill-defined, because it's not clear now which side to pick the content scale. For the people familiar with Compositor's CC's architecture, there's this thing called the content scale. What the hell is the content scale that's appropriate for something that's scaled 100x in one dimension and 1 in the other?
It's a good
You end up
question.
in a world of pain.
Yep. Sorry, Runa.
Yeah, I have a question about. I have a question about when you're changing the transform in the UIWorker, you're not guaranteed that the layer you're changing have been become a graphics layer.
Yes.
So do you feed when you say that you're going to change the transform in the UIWorker, are you then feeding that back into the compositing reasons or something?
Okay, so I don't need to repeat the question. You had a microphone. That's awesome. So it's great. I don't forget. So yes, I do feed that information down through the system. In fact, when you bind up a property, it's a lot like saying, I will change that property.
Exactly. So you don't at the same time say will change in the document. You can actually leave that out and just use the UIWorker stuff to force it.
In my current implementation, that's the case, yeah. And if you were to, say, try to bind a property on a thing that you couldn't actually, promote, to use our compositor terminology, it'd throw on you, which is something that I hadn't mentioned before. The same thing would happen if you tried to bind one of the properties that we're not allowed to animate. If you tried to animate the text size, for example, I can't do that right now because I haven't implemented it, frankly. One thing that's worth noting, though, is that we are, through slimming paint, hoping to move away from graphics layers. So this really will turn into knobs, hopefully, in a display list. So we should get a little bit more flexibility with what things we are allowed to fiddle with. Yeah. All right, I'm going to call it at that. If you'd like to see the demos up close, come see me. Also, please do ping me if you've got ideas about how to make that API a little bit less grody. Thanks.